Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to Cloud Test Lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
And even if you didn't handle these exceptions, the compiler won't give any complaint. In this case, you can see that I'm able to compile the file. I don't have any issues. But in case of checked exception, these two are checked exceptions. There are plenty other available. So those checked exceptions, they are supposed to be handled at the compilation phase, which means you are supposed to handle those exceptions. So all the subclasses of runtime exception, like arithmetic exception, null pointer exception, index out of bound exception, these are all runtime exceptions, which means unchecked exceptions, and it's not required for you to handle at compiler level. That's what we have done at this level now. We'll see how to handle this particular program, and then we'll stop the class. Syntax for exception handling. The first thing is try block. You need to specify the statements within your try block, whoever might throw an exception. See, you can have any number of statements before this, or you can have any number of statements after this within your method, no issues. And these blocks will be going to specify only within the methods. Either you can specify within static method or instance method, that doesn't matter. When you specify the try block within statements or with the statements, a try block, it should associate with a catch block. If at all, if you haven't specified the catch block, then it will be going to throw a compilation error. And once you have ended your try block, there shouldn't be any statements in writing your catch block. You shouldn't write any statement in between try and catch block. A catch block, it should immediately follow the try block. If you have any exception which is raised before the try block, let us say if the exception has raised at this level, then Java won't use this catch block for handling this. It will be returned back to the caller because you are not specifying that this code might throw an exception. And when you write, let us say you are writing 5 statements. First statement, second statement, third statement, fourth statement, fifth statement. Let us say the exception has occurred at this level. Whenever an exception has occurred, it will immediately transfer the control to the nearest catch block. So that means whenever an exception has occurred, it won't execute the rest of the code available inside the type block, and it will start executing the catch block, and it will start executing once after executing catch block. It will start from immediately after the next line of catch block. So whatever the statements that you have specified after the exception statement, they won't be executed whenever there is an exception has raised. Let us say if this doesn't throw any exception, it will simply follow this procedure and it will execute all the 5 statements. It will see that there is an end for try block. It won't use any catch block statement because catch block will get executed only when there is an exception, and it will start executing once after immediately following the catch block closing brace. Let us go and write here now. We forgot one more thing. Currently, we have specified that at this level, exception has raised. And whenever an exception has raised, Java will be going to create an object for the exception. So if it is a divide by 0 exception, Java will throw arithmetic exception. If there is a null pointer issue, Java will throw null pointer exception. If that is SQL related one, Java will throw SQL exception, IO exception, or index out of bound exception. If you don't know what kind of exception that will be going to raised by your JVM, you can simply catch the exception by using top level. See, let us say at this level, Java will throw arithmetic exception, and you will be going to catch only the arithmetic exception. So when Java will throw an exception, will raise an exception, it will create an object of arithmetic exception, and it will put that object with AE. And you can make use of this AE, and you can print the stack trace, or you can print the message, or you can print any kind of information related to exception. So whenever an exception has raised, Java will construct an exception object, and that exception object will be given to your catch block. If you didn't use correct exception object, let us say you are handling arithmetic exception and Java has raised index out of bound exception. Java won't pass the exception object to you within this catch block, and it will consider that you are not handling the exception properly, and it will be handled by default handler. So whatever the exception it might raise, you should catch the same exception object, or else it will be handed it over to the default handler. Let us say you don't know what kind of exception it will be going to throw. In that case, what you can do is you can simply catch the superclass level object, superclass reference. You can place that. I don't know what kind of exception that will be thrown. Either it might throw null pointer exception, or arithmetic exception, or it might throw SQL exception, or it might throw IO exception. What you are doing, you are specifying superclass reference. Java will make use of this, and when it has constructed the arithmetic exception, it will construct the object like this, and it will make use of superclass reference, and you can easily use superclass reference to point a subclass object, and Java will make use of that particular concept, and it will be going to embed the subclass object to your superclass reference, and it will call the catch block. So this is the first usage of your superclass reference to subclass object. See, you might get index out of bound, or you might get null pointer exception. If you are familiar, or if you know that the execution of this particular line will throw arithmetic exception, then you can go and catch directly arithmetic exception. Let us say if you are not aware, let us say you are writing 15 lines, and within the 15 lines you don't know what kind of exception that will be going to raised by your code. At that time, you can go and catch the top level or superclass level, and you can make use of superclass reference, which is exception reference, and whatever the exception that will be going to raised, it can easily point to a subclass object. See, ultimately, when Java calls the catch block, it will be going to embed the object, whatever that was created with respect to the exception, into your E. Right? This is just like a method call. You can think like method name and method parameter. So when Java sees that you are handling superclass reference, Java can easily create a subclass object, which is your exception object, and you can easily point to superclass reference to subclass object, and by making use of that concept, Java can call the catch block, which you have associated with the try block. So in our current case, let us comment this code and perform C equal to A by B operation. And now what we have mentioned, we have specified that we are going to handle with respect to try block. And currently I know that it will be going to raise arithmetic exception object. So I'm catching the arithmetic exception object, exception handled. So once you have handled, so currently what we are doing for int c equal to a/b, let us write one more statement once after this. Exception not occurred. So that means if at all if you pass 10,25, the exception won't occur, and it will follow in this way, and it will enter the try block. It will execute this line 10/25, which is a valid expression, and it will execute this line, and it won't take a look at the catch block because it didn't get any exception, and it will start processing from sysout statement. Let us say an exception has occurred at this level. Whenever an exception has occurred, Java will construct an exception object, which is in this case arithmetic exception object, and you are handling that particular exception also by using catch block. Java will make use of this block, and it will call the exception handler. This is your exception handler code. Once after this, it will start the processing at this level. But only thing is, whenever an exception has occurred, it will immediately transfer the control to catch block, and it won't execute any line once after the exception has occurred. But currently, I'm getting some error here. What is the error? C cannot be resolved to a variable. Why I'm getting an error for C?
It is being initialized in the try block in C.
Exactly.
It's a block variable.
Exactly. So you shouldn't specify any variable inside the try block and access it outside the try block. This is once you have specified any variable within the block statement, that will be local to the block, and this variable will get destroyed once after the block execution has completed. So this variable is not at all accessible outside the try block. So you should specify that, or you should declare that this is a method level variable but not a local variable. Once you are handling this, let us go and execute this. So first case is 1025 you have passed, which means you won't get any exception. You are able to perform the value, expression. Okay. Initialization completed, it has printed, and once after that you are performing the operation, and you can see that this statement has executed properly. And whenever there is no exception, we have mentioned that it won't execute the catch block at all, which means you can see that once it has printed exception not occurred statement. This is the statement. It hasn't printed this statement because it hasn't entered this block at all. Once after that, you can see that it has directly executed this particular line. C value is 0. Let us say change the value to 0. Here what happened? A is equal to 10, B is equal to 0. Let us go and execute it now. Again, the process starts in this way. C equal to A/B, 10/0. Once you have performed 10/0, it will be going to throw a divide by 0 error, which means Java will be going to construct an arithmetic exception object, and it will be going to call this particular catch block. And here you can see that the exception handled method was called, and once after that, immediately it will be going to transfer the control to next line after the catch block. Here exception has handled properly and the value is 0. Let us say I'm not catching the exception properly and I'm catching some other exception. I'm catching now index out of bound exception, which is not an arithmetic exception. Let us go and execute now. When you are trying to execute this code, you have a try block. This will be going to see that this has constructed an arithmetic exception object because it has raised an exception. Do we have the corresponding catch handler available with us? No, we don't have corresponding catch handler with respect to our try block now. In this case, your JVM sees that, hey, you are not catching the arithmetic exception. So that means you are not going to handle the exception on your hand, with your hand. And it will be going to transfer the control back to the caller. And in this case, the caller is the main method caller, which is JVM. JVM process this by using default handler. And you can see that this is the stack trace method. And the next step, what we have mentioned, if you are not aware of what kind of exception that will be going to rise by your code, you can handle at the top layer, which is exception layer. See, you can handle at the throwable layer also. But if you handle at the throwable layer, all the error related, all the exceptions of error types, they will also get handled. We don't want this kind of exception types will get handled by our code. That's why we are specifying only the root class as exception class. See, when I have executed this code, currently I'm catching exception class, exception object, or exception reference I'm using, and I am catching all the subclass objects. So when it has raised an exception, it will construct an arithmetic exception object. Once after constructing arithmetic exception object, it will verify are there any matching catch handlers Currently, we don't have an arithmetic exception or reference available for catch handler. Then it will verify in the hierarchy, are there any superclass references which can take the subclass objects. Currently, we have one which is exception reference, and we can handle this, and we can convert this to handle subclass objects. That's why Java can identify that, yeah, you have an handler available, and I can call this particular one to handle the exception. That is how Java has resolved the call. And once after an exception has raised, see, currently when we are not handling the exception, we are able to see some kind of stack trace, and we are able to see some kind of exception message. If you want to see such type of stuff, you can go and take a look at the API for all the class files. See, currently these are all class files, which means it consists of certain methods and members. So let us go and verify the first class, which is java.lang.exception. You can see that your java.lang.exception consists of one variable, and it consists of 4 constructors, overloaded constructors, and you can see that it is extending throwable. We already mentioned that exception is derived from throwable class. Go and verify in throwable class if there are any methods available. See, currently we don't have any methods related to exception class. At our throwable level, you can see that these are the constructors, and you can see that these are the methods that are available. So some of the methods that we can use: get message, get localized message, which will be going to provide you the message which we have seen when an exception has occurred previously. And you can see that the print stack trace method. You can make use of print stack trace method, and you can print the stack trace that has occurred with respect to your exception. So what is our current exception? Arithmetic exception. Take a look at the API. Your arithmetic exception is going to extend from runtime exception. That's what we have mentioned here. And you can see that your arithmetic exception doesn't contain any methods, and it contains only 2 constructors. The first one is default constructor, and the second one is constructor with an exception message. Most of the classes in exception handling, they will consist of one default constructor and another one which accepts a string parameter, which is used to specify the error message. Most of the exception classes, they will contain a constructor, overloaded constructor, which accepts as a string, and we'll take a look at them in the next class. So currently, you can see that it is making use of the inheritance concept and all the required methods. See, the print stack trace method is required for all the exceptions. So Java has followed the inheritance concept, and it has declared and provided the definition for print stack trace at top level itself. So the throwable class consists of a method which is print stack trace, which means this method is available at this level, this level, this level, at each and every subclass level, because Java follows multi-level inheritance at this layer. So that means once you got the exception object, here you got the exception object, you can make use of the exception object, and you can easily call the methods. Let us say exception message plus AE dot get message. Once after that, I'm calling print stack trace. The print stack trace is going to return a void. You shouldn't use that within system.out.println method. Your println method won't accept a void return type, but your print stack trace, it will return a void value, which means it won't return anything. It uses sysout statement inside the print stack trace code. You can just go and call that method. It will be going to print the information. So here you can see that exception message, which is divide by 0. And when you call print stack trace, you can see that the stack trace has printed. So the stack trace, which specifies the exception class, exception message, and that stack trace where exactly the exception has occurred. Normally, even though if we handle the exception, normally all of our exception blocks consist of this particular method call, because we want to verify where exactly the exception has occurred. That's all for today's class. Let me know if you guys have any doubts.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website H2KInfosys.com. On our website H2KInfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.